Welcome back. We continue our jump through the week 1 in-class problems. So here we are told we have 3 sets, R, S, and T. And there's 2 problems. There was actually several more, but I want to focus just on these 2 in this video. The first one says we're going to assume that the set R is a subset of S, and that the set S is a subset of T. And we want to conclude that R is a subset of T. Now, from a pictorial point of view, this actually should be pretty straightforward. You have a set R, and knowing that it's a subset of S, so okay, here could be R, means that it sits entirely inside of S. And then S is a subset of T, so we know that S sits entirely inside of T. And so from pictures, we can see R is a subset of T. If we want to make this precise, though, because proof by picture is a little bit tenuous of a technique in math, let's write this down very carefully using the definition of everything. So R is a subset of S. Well, we got to know what that means, right? What does it mean for R to be a subset of S? It means every element of R is an element of S, right? So this tells you if X is in R, then X is in S. Okay, so that's what this means. Okay, what does S contained in T mean? Well, S contained in T means if X is in S, then X is in T. Okay, finally, we want to prove that R is contained in T. Okay, what does that mean? Well, that means if X is in R, then X is in T. Okay, well, this actually should indicate how we should proceed, right? To show that R is a subset of T, we need to choose an element X in R. So we let X be an element of R. Right? Now we want to get that it's an element of T. What we know, though, from this blue part is that if X is in R, then X is in S. So let X be an element of R, we can now say since R is a subset of S, we have X is an element of S. Okay, but now we can jump to the green. Once we know X is an element of S, we know it's an element of T, right? These are 2 assumptions we have. All right, so again, as S is a subset of T, we conclude X is an element of T. Okay, so we just showed when we chose an element X in R, it also was an element of T. Therefore, R is a subset of T. Okay, that's it, right? It looks like it should be harder, but it really just comes down to definitions. Okay, so let's try B now. So we want to show in B that if R is a subset of S, and if S is a subset of R, then R is equal to S. All right, well, we know from up above, right, what R is contained in S means, right? If X is an R, then X is an S. And we also, of course, could turn that around, right? If S is contained in R, that means if X is in S, then X is in R. Okay, now what does this last condition, right, the hypothesis actually mean? Right? Well, for this to be true, we need that every element of R is an element of S and vice versa. They have the same elements, right? They have the same elements. Okay, but what did we just assume here, right? We just assumed if X is in R, then X is in S, right? So every element of R is an element of S. And the second thing says if you have an element of S, then it is an element of R. So every element of S is an element of R. So we could write that down. We'd say since R is contained in S, every element of R is an element of S. And similarly, so some commas there, since S is contained in R, as a subset, every element of S is an element of R. Thus, R equals S.